All right, so without further ado, let's let Oren tell us about predicting popularity of text space.
Okay, thanks. Yeah, so I'll just say I was not recognized at all. The algorithm was recognized, not us. So the algorithm is one of the something by people from the Hebrew. Okay, yeah, so today I'm going to talk about linguistically motivated algorithm for predicting popularity of textual memes. And this is joint work with Ari Rappaport, which was my supervisor at the Hebrew U. I'm going to start by just saying the task in general, because when I move into the introduction, I want you to keep the task in mind. So the task is given a few options for new phrases. Can we predict which one will be accepted? And specifically, we're talking about Twitter hashtags as the new phrases, and we could discuss, which we will not have time, unfortunately, what new phrase means and what accepted means. And I'll get into more specific details later. Yeah, I think because we started a bit late, I'll have to do some adjustments on the fly. You could still ask questions, but again, if I don't know the answer or if it's too long, I will say, okay, we'll just take it offline or for after the talk. Yeah, okay, so the agenda. I will start by giving some linguistic introduction, which I think is really interesting and important, because when we do machine learning and when we do natural language processing, many times we tend to forget the social and the cognitive processes that kind of generate the language or the signal that we're processing, and we tend to focus on the algorithm and the engineering. So I will talk about that, what's the motivation and inspiration for this specific use of the algorithm. Then I'll be more specific and formal about the task. I'll present the algorithm in a high level. And again, if you want to ask about the details, you should definitely ask. And then some experimental results as time permits, and error analysis, which is, again, I think very interesting. And it goes back to kind of the motivation, the linguistic and social phenomena that drive this whole thing. Okay. So I will start by this. This is, I think, if you are interested in language in general and you want to read one book that is popular but yet very substantial and interesting, and not just, okay, this is a popular book, so we're just going to write some popular stuff, you should read this book, The Unfolding of Language by Guy Deutscher, and I'll read one paragraph that's very relevant here and to what's happening in Twitter. So the most important discovery we have made so far is that language is in a state of constant flux. While no one in particular seemed to be going about changing it, a few deep-rooted motives that drive all of us, that are economy, expressiveness, and analogy, create powerful forces of change and ensure that sounds, meaning, and even structures are always on the move. So this is something we have to remember when we talk about language, when we do language processing. Okay, the other thing that kind of inspired me toward this work is what we call, like linguists, not we, call optimality theory. And in general, optimality theory started at the 90s, and it became like a big framework for linguistic work, also very controversial. And it means that it tries to model or understand how observed form of language came into existence by modeling some priorities between various constraints. And I'll give two examples. One because it's just very immediate, and the other one is more relevant to the work. So I don't know if you remember the movies, The Truth About Cats and Dogs, or know this fantastic cartoon. But from a linguistic point of view, if you want to know the truth about cats and dogs, so this is the truth. Okay, when we want to use plural, so we all know that we just add an S, right? We say cats and dogs, we write it with an S. But when we actually pronounce it, we're going to pronounce cats with an S, but dogs with something that is, it's not like a hard Z, but it's more like a Z than an S. And you could try it yourself, and this is true. Maybe not for me, because I'm not a native speaker and I have a funny accent. But for most, I guess, native speakers and also many non-native speakers, this is correct. Now, our first grade teacher didn't tell us, okay, when you say dogs, you have to pronounce it with something that is not exactly an S, right? It's something that we naturally do. So optimality theory, again, will say, okay, what are the phonetic constraints and the way we produce sound, like physically produce the sound? There are different constraints here. And we know that we want, like, again, we are aware that we want to use an S, we just don't do that, okay? So why we do say Z instead. So this is what optimality theory tries to explain and address. Now I'm going to move to another example, which is very, very relevant here, and I'll talk about like expletive infixation. I don't know if does anyone know what that means? Except Tsur, which is a linguist. Okay, so expletive infixation is when I want to stress out something, I take an expression and I kind of cut it in the middle, and I insert some explicit language in the middle. For example, I'll use the F word, and I'm going to use it once. Okay. It's relevant. I didn't make up these examples, by the way. I'll show you. I have the proof here on the slides. Okay, so I could say there is no way I'm going to use explicit language in the talk, right? And I could say there is no fucking way I'm going to use explicit language in the talk. Okay, so this is expletive infixation. So this example is taken from a very interesting paper with the, I would say, a boring title, the binarity in English nouns. Okay. And it's hard to see, but he said if you want to say you are from Minnesota, and no one knows where Minnesota is, right? So how would you cut Minnesota in half and add the F word in the middle? And there is one way to do it. Okay, so there is no one way to do it, right? You could try other ways. Like I encourage you to try, like quietly, don't shout, okay? So this is the pardon my French, okay? So all of you, I guess, or definitely most native speakers will do it this way, okay? We'll say mine, pardon, sota, and not in any of these ways. It doesn't sound right, even though, again, no one taught you that there's no rule that tells you how to do that, okay? So this paper tries to model it again, different constraints, and why we see, like, how do we model it, that we see this observed form happening. Okay, now you would say, okay, Minnesota, I have 2 syllables here and 2 syllables there, so I just split it in the middle. So he gives 2 other examples here. So there is bandana, okay, 1 syllable and 2 on the other side, and Tennessee, 2 syllables on the beginning and 1 syllable at the end. And again, it depends on the way the word is, the composition of the word, like what is the onset and the coda and the nucleus, etc. So this is basically what inspired this work, and I would say that I read this paper like a million years ago as an undergrad, and I think the only reason I remembered it is because of this example, so you're probably going to remember it too. But seriously, it was very inspiring after some time, not when I was actually reading it. Okay, now let's go back to what we're actually doing. So we have to remember that language is changing, and we add new words, and words that exist change meaning and sometimes slightly change in form. And new words like neologisms, we know many of them, like laser, brunch, McJob, cyber, hashtag selfie. All of these are different phenomena, right? Laser was an acronym, brunch is what linguists call portmanteau, meme is original Greek language, but again, the way we come to know it is by Richard Dawkins, and in the past few years, like it's very popular and highly used, etc. But when we talk about neologisms in our context, I talk about Twitter hashtags. Okay, and Twitter hashtags could be any of these kind of types. It could be like just a new word that I added in a hashtag, and it could be like 2 words like together, and it could be something that is completely new. Okay, yeah, so the task. So this is a task the way we defined it before. If you don't know what hashtags are, so this is the trending hashtags and phrases on Twitter. I don't know if you could see that from half an hour ago. And you could see that they are very different with the way they're written, capitalized, the way words are like combined together. This last one, for example, is about a murder trial that is happening just now, and you could also see like everyone uses it a slightly different way, the way it is written, and also the way, I would say, the syntactic or semantic role it has in the sentence is different. So this is a rich phenomena, like to talk about hashtags as new words and new ways to use words. Okay, so what we're gonna do? Okay, so we have a lot of data, a lot of Twitter data. So we could find the hashtags. We could look at the frequency or the counts actually for each hashtags, how often or how many times it is used in our data. So this will be our kind of objective here. And then we're going to represent each hashtag as a vector of features, in this case, linguistically motivated features. And we're going to use machine learning. We're going to train a model on some of the data and test it on the other half. Okay? So this is pretty straightforward. It's so straightforward that we actually did it before at 2012. And this paper, I like it a lot, but I think, and it was published and it was like well received and cited, but there is something I don't like about it. Okay, so I kind of reject this paper now. I don't fully reject it. I think there is a lot into it, but I think that the way we treated hashtags in that paper is naive in a way, because we just compared each hashtag and we predicted the popularity or the popularity of at scale of each hashtag. But in general, what we did is by looking at hashtags that has no connection to each other. We compared each hashtag. So we looked at Tea Party and When We Were Young, which is kind of a Twitter game, and Iran election. And obviously, they don't belong together. Okay, so we managed to predict well, and we used temporal trends, and we used features that are relevant to the network structure and topology, and we used features that are related to the content of the hashtag. But all in all, the task didn't distinguish between hashtags and between types of hashtags. Okay, and I think what we should do, and what we did like in the work I'm going to presenting now, is to look at hashtags from sets of similar hashtags. Okay, we call it like semantically interchangeable sets or semantically interchangeable hashtags. So let's look at it. So Iran election for Iran, Green Revolution, Iran election. All of these were pretty popular, or at least some of these were pretty popular. But what we want to do is not whether Iran election is more popular than Follow Friday. Do you know Follow Friday? So because it was huge at the time I collected this data, I think now it's not so popular. But it was by far like orders of magnitude more frequent than any other hashtag. What I saw is FF, and I had no idea what it means at the time. And I had to go back and start checking, which is, again, I will talk about it at the error analysis at the end. So we don't want to compare Iran election to Follow Friday. What we want to compare is, will Iran election this way will be more popular than Iran election with lowercase and more frequent than Free Iran, for example. Which, yeah.
I'm kind of curious, like, to what extent is this, is this due to sort of, does this have anything to do with linguistics, right? If I'm the one, right? Because you could imagine that that this is, that this is like, different brands, right? Of, right? This is just like different communities, or
Yeah. Okay, so I'll get to that. That's I will get to that. Okay. First of all, I have to say that when I say linguistics here, I mean linguistic in kind of a broad sense, which combining the way we look at words, the way we're used to use words, and the way the community uses words. But I will refer to your specific question in a few slides, and if I don't, so just remind me, okay? Okay, so this is what we want to compare. We want to compare the hashtags within each of these sets, for example. If we go a bit more formally, so we have small sets of semantically interchangeable hashtags, and we define an order, and we say that HTI is more frequent, right, than HTJ, if the counts that we actually see in the data show the same thing. And then we have some loss function that we kind of punish every time we predict an order that violates the order that we observe. So we give some punishment. And we're going to try to minimize this function, this loss function. Okay? Now, if we manage to get A, prediction accuracy, and B, to come with model that is a bit interpretable, and the features we're using are what I'm going to call linguistic features in the broad sense, we may be able to say something about how we use language, how we produce new words, something about this kind of mechanism, at least in a shallow way. Okay, so the major constraints or factors that I want to put into the model, I want to model somehow efficiency or economy. Remember it from the first slide. This was like a major force that drives the way we make up new words or change language. We know it as Z-flow. Okay, so there is some tendency, not always, but some tendency for like words that are more frequent to be shorter. On the other hand, I want to be well understood, right? If I just say, okay, this is a very, like, I don't want to just use, I would call it a compression algorithm, right? To come up with, okay, this is very frequent, so it will be mapped to a short sequence that no one knows what it means. So I want to keep what I'm saying approachable and coherent. I would also say that if I use definitely on mobile device, typing is really, really annoying. Definitely when I get to capitalize things, Yes?
So are you also considering the sound?
So I don't consider the sound in this work.
Since we can speak to our smartphones now?
That what, I'm sorry?
We can speak to our mobile
Right.
devices.
So no, I definitely didn't consider it for that work. I have another work which is, I didn't even plan to talk about, that identifies kind of the native language of a non-native English speaker based on sounds or sequences and syllables. Not in that work at all. But that's a good point. I don't know if the data is available. Like if
so it's the orthographic features of the
yes.
words, not
Yeah,
the sound.
yeah,
Okay.
completely orthographic. I wonder if someone has this data, or if Twitter somehow have this data, if the tweet was composed by speech to text or not. That's a good point, interesting point. Okay, and of course in Twitter I have the 140 characters limit that puts everything in like under like a severe constraint for what I want to say, how I want to say it, and how understandable will that be. Okay, so the algorithm itself. So the algorithm is a modification of gradient boosted trees that was presented and actually used by Yahoo to re-rank their the web results given a query. And I chose this kind of framework because I thought it will give like relatively high interpretability. It allows you to learn nonlinear models because you could combine many trees, and the trees you can go back and forth between features in the trees, and then when you add another tree you could go again back to the next to the same feature you already visited. And I thought that was a nice trick to convert regression learning to ranking, and ranking in small sets and small groups. So how does that work? So we just at the beginning, we just remember that we have what the actual counts for each hashtag. To re-rank, you type in a query, there is a general algorithm that returns like many results, and then they re-rank the results they use a similar algorithm. Not exactly. Like I actually tried to use what they described that they're using, it didn't work at all. So I had to modify it a bit to work on this task. I have some assumptions why it didn't work, but
what's in their application? Sorry.
What? I'm sorry?
What is their application again?
Okay, so you type in a query in the search engine, you get a lot of results, like not you, the computer gets it, and then they do another extra layer of re-ranking the results, or re-ranking the top results based on something similar to this algorithm. Okay, to improve the accuracy or user satisfaction with the results. And it takes into account, in their use case, the number of time people typed in a similar query and which links they clicked on, given the same a series of results. Okay, so the kind of the parallel here is that I have in my mind some concept or a very general basic hashtag, and there are few ways to type out, I would say, this concept or this hashtag. and I would kind of re-rank it based on different constraints, and I learn it by, instead of clicks, by the number of times I actually saw it in the data. Okay? Okay, yeah, so I started by just using a regression, like predicting some target values that are not, obviously not targets, the real values. I would start with 0, but you could start with whatever. And then you're going to loop till something happens, either convergence or you restrict your epochs or something like that. And you apply some regression algorithm, like learning regression algorithm. In my case, I'm going to use regression trees on the values. Then I'm going to check if I predicted the order correctly. I don't really care about the final, value that I predicted. All I care is about the relative order, and not only about the relative order, about the orders of predictions within the small sets. Okay, and then I do some gradient descent, like I update the predicted values from the previous stage, and I learn again another tree, another regression. So basically, I have the observed counts, I have the predicted values at time t minus 1. Each hashtag is obviously represented by some vector. And again, what I predict, I build a a regression function based on these values, okay? And then I check if what I predicted within the small sets violates the order that this show me. If it violates the order, I update by some. Okay?
Sorry, Oren,
Yeah.
how big is M and how big is N in your examples? Like N is like in the order of 10 or something like that.
Okay, so M is in the order of a few dozens, like between 10 and few dozens, not more than that. M is is relatively very small. N is in tenths of thousands, but I never compare like all the possible pairs, right? I only compare as few, and I'll give the numbers. I have a table giving.
N is on the order of tens of thousands?
N is in the tenth of thousands, but I don't compare all of them. I will show you again. You're kind of predicting my slides. Okay. Yes.
So I think there's two different kinds of self-similar things, but I'm pretty sure even though Twitter will, in this specific case, Twitter will represent case sensitivity as entered. I think when you search, they're case insensitive, so that as far as Twitter is concerned, it's really the same thing.
Right.
Versus, there's 3 different ways to describe the event you're going on, and predicting which of those will become the dominant one.
Right,
It's more
right.
interesting than predicting which case-sensitive version will become the dominant one.
Right. So you are definitely right.
Okay.
And this is like a major issue here, which again I'm planning to talk about in like 2 minutes.
Okay.
And it's a huge elephant in the room, and I'm going to talk about this elephant, what's the problem, how we kind of solve it, and how we try to solve it. I'm going to talk about it. Okay. So this is a pseudocode. I don't expect you to actually read it. I put it here just to demonstrate something nice about the algorithm, what I think makes it interesting is the play between working on specific hashtags for the prediction, for the regression learning, and for the rescaling of the target values, and working on pairs of hashtags when I actually do the ranking and I measure how well I'm doing. Okay, so and this is very nuanced here. Okay, because again, I do not work on all the possible pairs. I work on possible pairs within the small subset, and I don't care if I get it completely wrong in the prediction. If I would take like 2 hashtags from different cluster and I would get it completely wrong, I don't care about that. But using this algorithm in the way I described kind of solves that. Okay, so some experimental results. So here is what you actually asked. So how I would translate your question, tell me if I'm wrong about it, to how do you decide what hashtags are semantically interchangeable, right? Because it all looked right. I had formal definitions and the math works and everything works. But what makes hashtags semantically interchangeable? And this is a huge question. So I found this cartoon on online, which I think is extremely funny. So there is a very specific event here, and everyone responds to this specific event, right? Someone is mugging someone here, and they all do like tweet some, like do something is obviously the most popular here. Yeah, do something, etc. Someone says doing something, ban knives, united for hair, hashtag. And the one I like to blame Bush. Okay, but obviously these are not semantically interchangeable, even though they all refer to a very specific event that happened. So this is a huge problem. And even in the case where we thought, okay, it will be easy to define these sets, it's not easy, it's not simple. People do a lot of random things that you definitely online, that hard to explain, let's put it this way. Okay? So we try to tackle a similar problem a couple of years ago by doing some clustering on hashtags and on tweets. We managed to do pretty good clustering if on like not so refined, I would say, subsets or topics like news, sports, music, etc. When we try to have like very fine-grained clusters of, again, what I now call semantically interchangeable hashtags. I didn't call it this way before. So we got some great results, like these examples here, like recycle and ecology, and NEDA, free Iran, Iran election, etc. This is extremely surprising because this is kind of a Twitter game that you would not expect these hashtags to be related whatsoever. And as you could see, they're reading in very different ways. And it's still like we got many of these Twitter games together. It's, I think, fascinating phenomena here. But we got a lot of clusters and small sets that either seemed like complete noise or that were just incomprehensible. And in order to really evaluate it, you have to go back to the thousands or tens of thousands of tweets that they appeared in and evaluate that. And we didn't do that, and it's practically impossible. So what we do is we backtest to two one very conservative and one just conservative solution. We looked at hashtags that differ in capitalization. Okay, there are different ways to capitalize hashtags, and some are very rich. And we had, when we called it caps, and we also had another way to define similar hashtags by if the stemming of the hashtags is similar. Okay, so this gives some more degree of freedom, I would say, or flexibility. And remember, hashtags could be like a sequence of words attached together. So if each word has a stem, so you have a lot of variability here. Also, by doing that, what you actually do is you kind of account, or you don't have to explicitly account for the network topology, right? Because if I have something in mind, like a concept, a hashtag with specific characters in mind, that's what I will try to type, and I will just make the choice of, okay, should I capitalize this or that or no? And it's not that, okay, some very influential node in the network use one hashtag, and I'm considering or not considering a very different hashtag representing that concept. Okay, so this conservative way also, like it's kind of good for us. Okay, a comment about significance. You could do because we use the counts that we observe in the data, we use it as our kind of labels. So we look at different degrees of significance, and this is how much hashtags differ, like the counts differ. So just very formally, if one hashtag appears one time more than another hashtag, so it's ranked higher, right? But this could be very random. Okay, you just you use it to one more, twice more the other one, so it flips the situation. So here I kind of describe what happens if I say, okay, I want at least count of 100, that the difference between them will be 100. So in the cups setting, for example, it leaves me about 5,000 clusters to check from. So obviously, the more significant the difference in the labeling is, I'll have less data to work on. But what I will learn will probably be a bit more accurate because there is more accuracy in the labels that I have. Okay, the feature types that I'm going to use in the algorithm. So I say I want to somehow include like production effort, comprehension effort, linguistic conventions, and domain incurred constraints, which is like typing and the fact that, for example, in retweet I don't have to type anything, I just retweet. And specific features will be num of characters, num of words, num of caps, all caps, proper names, locations that appear in the hashtag. If the hashtag contains an acronym, if there are specific suffixes. In the case of the stemming, they would also have a Levenshtein distance, which is the distance of the hashtag from the shortest form of the stems, etc. And here is what I learned. So I learned a sequence of trees. Okay, so this is an example from one run. This is the first tree. Again, this tree was, I said, okay, we're going to have 3 levels. We learned the tree in a green manner, like the way you learn regression trees. So this one specific tree, and remember the algorithm creates a series of these, will predict the following for your run election, for example. And this is actually the right prediction. Okay. So this was the most popular one, then this, and then this, okay? But if I check, for example, for this hashtag, again, you learn a lot of things by working on hashtags. I had no idea what that is. You know what? Does anyone know what this hashtag means?
Lady Gaga.
Lady Gaga, yes, and it's Video Music Awards apparently. It's, I had no idea. Okay, so if you look at this, so it will. Again, don't have to look on the numbers like comparing the Lady Gaga thing to the Iran election. The Iran election here seemed to be more popular, and I'm not sure it was more popular in what I actually see. But when I compare these 3, for example, so I get that these 2, that's the right prediction, are more popular than this, but this specific tree that I learned couldn't tell me which one is better here. Okay? So I would call it that this tree is idle for these 2, and hopefully, because I have a series of trees, hopefully the next tree or the next few trees will resolve this idleness or indecisiveness about these 2. And of course, I could say have bigger tree, larger tree. So here is another tree. What's nice here, you could see that in this level, it's all about, like it happens, right? I didn't design it this way, but it's all about the length, either in characters or in words, of the hashtag. And here is the number of shifts that I have. And here again, I go back to the shift number, for example. And again, this tree correctly predicts the order and the ranking between these 3. Do you have any idea what that is, Dikot? So, no? It's top conservative, again, had no idea. But it's a very popular hashtag in the political domain. Used by Republicans, and again, like there is no reason for me when I think about it to use one over the other, but apparently people have strong tendencies. Okay, so we tried our algorithm, but we also compared it to a baseline and an SVM rank because to see what's happening. So the baseline simply predicts the shortest, the least effort, like no suffixes, no capital letters, no nothing. And it works surprisingly well. Because many hashtags are just one words and there is no reason to capitalize it, just one noun, okay? So no reason to put capitalization, so it works. But it had hard time to account for other types of hashtags. SVM rank performed better than the least effort, and in all cases, both settings, stems and caps, and in different significance level, the GB rank performed better than the SVM rank. And again, the more significant the observed values are, the labels are, or less noisy I would call the labels are, obviously we get better prediction. You could also talk about the complexity of the model, how many trees, how many levels. I'm going to skip that. I will just say 2 things. When you have too many trees or the trees are too big, you lose interpretability, right? Because there are too many trees and too many roots for each thing, for each hashtag. And B, you get at some point you always start overfitting, okay? Because you really have a long rule for each specific hashtag. This is interesting because what you see here is that the more trees you add, the more decisive you get. Okay, because if you remember, some trees were idle regarding some hashtags, and some also just made the wrong prediction about the ranking. But when you add trees, so this is the majority, like by what majority I win when I add trees. So for example, when I have 7 trees in the caps, so the majority was the average majority was 3 trees, which means either the 2 trees were predicting that one hashtag will be more popular and 5 trees predicted the other hashtag, or that 4 trees were completely idle and 3 trees were very decisive about the one hashtag that works, which is nice to see the stability of this model here. And now I'll just do a quick error analysis. So I think there are 3 types of problems, or not problems, challenges that are problem to these types of algorithms, or in general to the way we look at these types of phenomena. So the first one is ambiguity, the second is canonization of language, of new forms of language, and the third is institutionalization. So ambiguity, for example, I don't know if I see the word dolphins, I don't know if it just saves the dolphins or if it's like a dolphin, so it's a named entity. Yeah?
So does this mean you're really just looking at the hashtags, or you're looking at the hashtags in the context of Twitter?
So I didn't look at the context in this work. I just looked at the hashtag. Looking at the context, it is problematic. It goes back to the 2 other works I mentioned, which we do it well to some degree, but not to the very fine-grained level we want to do it here. So, okay, or Steve Jobs. That was the data is from 2009 until 10. So there was a lot about Steve Jobs and a lot about jobs in general. And we didn't distinguish this, and obviously the algorithm can distinguish this, and it puts noise to the counts, right? Because we look at these 2 and these 2 as just the same one, like competing hashtags, and they shouldn't be. Another more interesting, I think, problem that we face is canonization. So you remember the Follow Fridays and the FF. So this is how it all started. At some point, at early 2009, someone said, okay, I want to do something for good karma, and every Friday I'm going to mention other users, so to pay a tribute, and it's like a recommendation. So someone immediately answered, okay, great, we need a hashtag for that, that's going to be Follow Fridays. Okay, I didn't process the data at that time at all. But then something interesting happened. So this is at the log scale basically, and what you could see here, that while in the beginning Follow Friday, the full words was the most frequent hashtag here, so at some point the abbreviations like the FFs became more and more frequent and surpassed the Follow Friday. So obviously this happens because at some point it is used so much by the community that everyone knows what it means. Also the tweet with Follow Friday has some specific structure, because it's Follow Friday and then usually like a series of usernames. So once the community knows what it means and what the context it will appear in, we could make it shorter. And it's easier, so we're gonna use it more. So we have the Follow Friday, the FF, and it's hard for me to see the colors, to be honest here, which one is the FF and which one is the FF, but they became the more popular. So we call it canonization. The thing is that in Follow Friday, it's kind of a qualitative example that I noticed because I didn't know what FF means. So obviously it exists as a phenomena in language, the way language works, the way language changes. It's just hard to track down. So I don't know to what degree this happens and like in our data. But when it happens, it may incur some noise in the algorithm. Okay, the third problem is institutionalization. So we used relatively old data from 2009 because we try to kind of account for that. But again, it's hard to see to what degree it exists in the data. But if you remember these 2 things, they are grassroots. Someone just made up a hashtag and people either use it or not using it. And sometimes same hashtag could be invented by many people at the same time. But another phenomenon that we see is this. But we see it like it existed less at 2009 and definitely more now. And is that there are like someone try to impose a hashtag on you, okay? And when someone, if a powerful, very influential user imposes a hashtag on you, it might not follow the kind of cognitive rules that we learned by the algorithm, or it would incur, again, noise into the data. So some examples for that. For 2012, the campaign of Obama, so I don't know if you remember that, Obama started using the hashtag Romnesia, okay, because Romney tend to forget things. This is a brilliant hashtag, and it went viral. But the thing is that, okay, Obama is not just a random person, grassroots, that's made up a hashtag and people liked it, right? This is a campaign account, and it was pushed again and again by Obama in the campaign with his millions followers and all other like campaign managers and members of Congress and everyone. And because they were very influential also by their followers. So Romnesia, which is in that case is, again, it's a very good hashtag, but potentially if it was a bad hashtag, it also had higher chances to be popular than just any other hashtag. We also see that in TV shows, for example, right? Every TV show nowadays has a specific hashtag that they're promoting, and they promote it, like they put a lot of money in promoting it. Like you see it on the TV, you see it if you buy a magazine and there is like an ad for the TV show, you will see that. And again, so this kind of strange hashtags that were made up by one man, but not in a grassroots way, like kind of imposed by some institution, either it's a corporate or a political campaign, will tend to kind of violate the rules, the general rules that we try to learn. We try to kind of quantify or check to what degree this happens in more recent data. So we looked at hashtags from TV show, from the most popular TV shows in 2013, okay, that had hashtags, and all these shows had hashtags. They had the official hashtag of the show that the network was promoting again and again, and there were some other hashtags that people and fans of the show were using. And so we looked at 113 programs, like TV shows like that, and in 97% of them, the one that was by far more popular than any other hashtag was the one promoted by the network. So again, when you kind of bombarded with hashtags by an institution, you will tend to use that no matter if it kind of violates your linguistic instincts or the way you would be using it otherwise. So these are the three kind of sources of errors or noise in our data. So just to summarize, so we kind of defined a new and refined prediction task. We used gradient boosted trees. We got some nice results for that. I just talked about the errors, and in future, in general, we may want to use magnitude preserving algorithm instead of just predicting the rank. So different like gaps in what we see may help the model better. We will try to maybe model that in the prediction. We would like, if we manage to come up with a better way, a better collection of semantically interchangeable hashtags. Again, this is a major challenge that we don't exactly know how to solve yet. I don't think there is an algorithm that does it well, at scale at least. And again, account for the error types, or at least try to properly quantify to what degrees this phenomenon exists in the data. I think it will be fascinated both from algorithmic and social/linguistic point of views. Yeah, that's it.
So I have a question. So I feel like a different perspective on this would be that that each hashtag is identified with maybe a person or a subset of people, right?
Mm-hmm.
And the popularity of it is just a testament of its virality, right? So you could, have you ever tried thinking about, and then there are all these models, right, that try to kind of like predict the influence parameters in the network, right? So you could imagine that, right? You could imagine that instead of doing, boosted gradient trees, right? Like, this kind of an approach, right?
Mm-hmm.
You could try to like predict the kind of an influence model in the network,
Right.
right? And then use that influence model to kind of to see how popular.
Right. So this is a good point. So I would say that in the paper from 2012, we kind of did that with different type of features, and we did take we didn't build like an explicit influence model, but part of the feature were like the degree distribution of people that used it in an early stage, etc. These type of things, and we showed that looking at the linguistic features and looking at the network features and also looking at early temporal trends, they all complement each other. And combining it obviously gives you the best results. In this specific case, we were trying not to look at the network structure. We were trying to see to see the way the hashtag is actually written, how that will influence its, I would say, popularity. But obviously, network structure and the influence is part of it. And you had a question?
So a couple weeks ago, we had a talk from Lillian Lee, who was talking about what makes things memorable.
Mm-hmm.
And it seems like there's something deeply similar about that work and this work, in that, it's not exactly memorable here, but it's, one of these things catches on and the others don't, and why. And so I guess I'm just wondering, how should I think about the similarities, if you are familiar with that work?
Right. So I'm familiar. I think it's a great word. And there are similarities. It comes from slightly deep. Okay. So first, interestingly enough, I don't know, it was exciting for me, and probably you didn't even notice that, but when she talked about this work, she did refer to our Wisdom 2012 work. Yep. Because there are similarities. Yeah, we try to look at things in the same way in that sense. And as for your specific question, so the algorithms we use are different, very different. I think that what is really, really nice and also different between these two works, but really nice at her work, is the way they created the set for the experiment, which was extremely creative and nice, right? To look at the same characters, very similar wording, very similar structure, but not exactly. So it's kind of having a controlled experiment without having a controlled experiment. So in that sense, that's a very different approach than what I was doing. And the similarity, of course, that by looking at different ways the same hashtag is written, if I don't allow myself hashtags that are very different in the character level, right? Just by capitalization or by different stems. So again, and see how many times they appear in our data as the label. So in that sense, it is similar. But yeah, I would say that I think we try to model similar phenomena and have similar interest in that case. Yeah.
I was just wondering if you can maybe clarify a bit the claim about this being linguistically motivated. I'm just not. Okay. I'm just wondering where's the linguistics here? I'm just not seeing.
Okay, so the linguistic is that, as I said, linguistic in the broad sense. So I'll not in the I look at part of speeches or at the parse trees, even though it might be interesting to add that. But part of what we're going to call linguistic is the length of the words, right? Or the number of words put together in order to create a new phrase. And B is the way I would write it. I would choose to write it. That is kind of a linguistic or cognitive decision that I'm making. And again, looking at stemming, different linguistic suffixes, etc. This is linguistic in a way. And yeah, what are the other features? And named entities. We also looked at named entities and acronyms and stuff, which is, again, named entities and the way we are kind of expected to use them or not expected. And when do we violate what we expect to use, that, again, kind of linguistic or lightly cognitive linguistic thing, like phenomena. But it's not linguistic in the way that, oh, let's look at the pos tag, let's look at this, you know, yeah,
I
what...
guess my issue isn't so much with the word linguistic, but with the word motivated. So, when I
okay.
think of linguistically motivated, I think it's motivated by insights from linguistics. But
Yeah, okay. Now I get the
by
question.
Insights from linguistics.
This is, this is, so, okay, so if you remember, I was talking about optimality
it's
theory.
Linguistic in the sense of having to do with language.
Right, but it's not only that.
And
Okay.
capitalization and how many words, that has to do with language. But that's
Right.
it's such a weak sense of linguistic that I
No,
wonder
so
if it's a useful way of characterizing the research.
Right, okay, so that's why I started with the two, I would call it linguistic observations / phenomena / frameworks of to understand that language is changing, which is not obvious, and in most NLP works we don't recognize that there is some change here, but more relevant is the optimality theory. I kind of use the way I choose to capital.
You're neither using optimality theory nor are you using information about the time course of the change.
Right. So in this specific work, I didn't use information about the time and the change. I did in the previous work. In the sense of optimality theory, I said that it's inspired by the optimality theory in the sense, or more specifically by the explicit fixation part. So we kind of choose in an unconscious process what to capitalize or where to break the word, where to break the hashtag in order to change, to do some effort. And
so this is a point of history. The expletive infixation long predates optimality theory.
As a phenomena,
yeah.
But
no, as a matter of linguistic analysis even.
Right, but one way of looking at it is by adopting optimality theory, and I have different constraints here. So again, optimality theory is not about machine learning, so here I didn't just model constraints and rank them, but the tree thing is like modeling the constraints, right? Each attribute kind of reflect some kind of constraint, and let's see how they work together to output some observed form. So that's why I call it linguistically motivated, okay? Because the motivation and the insight I brought from that's actually what drove this one. But again, not in a very explicit way. Okay. Yeah.
So we stipulate this as correct. Then what can you do now that you're able to make this prediction correctly? And in what time frame can you do it? Because, I mean, maybe as a practical matter, an interesting thing would be identifying an emergent phenomenon more quickly than other trending mechanisms might identify, or there's probably some other things too.
Right. So the one thing I thought of, which is extremely practical, is that even if you're a campaign or an institution or like a corporate and you want to come up with a hashtag, so of course you could come up with whatever hashtag you want, which could be very random and put a lot of money in it, and eventually it will catch. But you could also craft it according to rules you learned. You see the trees. Okay, I have a show to promote it based on few words with an acronym inside or not. Let's make it a bit smarter. So that's one way. The other thing is to really try and understand what are the constraints here and how they work together when people come, type, utter, invent new words that will or will not be used.
Okay.
Yes.
have a question, it's kind of related to the last two, which is that I think a lot of the sort of high dimensionality of hashtags you're kind of squeezing out with these really tight clusters. Right, so could you say just a little bit more about this point in the future? You said you tried a few things about trying to find more relaxed clusters.
Right.
Maybe by using like, news article links or something like that, or?
Right, so I try to make more relaxed clusters. It's just very hard, okay, so for this task, it's not only about, clusters that seem to work together, to be in a way coherent, you really want it to be interchangeable. So you would need something that is very specific and very fine-grained. The thing is that the way we try to do that, when we went to the really fine-grained clusters, it was very hard to evaluate what's a good cluster and what's not. I don't have a solution for that yet. I don't know if anyone has a solution for that. I think the solution will come like something similar to come up with a very conservative definition and try to elaborate it, and not like bottom up and not top down in that sense, but I really don't have any better idea now. Yeah, if that answered the question. Okay. So thanks.